Hi everybody, this is the Waku.js private messaging hackathon submission by Victor as per update. What we managed to do was try and integrate the baseline protocol with the Waku.js implementation. So for those of you who don't know what the baseline protocol is, it's actually a combination of cryptography, messaging, and blockchain to allow complex and secure private business processes on a public mainnet. So the mainnet can be Ethereum or any other public decentralized blockchain. Currently, Ethereum is the main focus for Baseline. So if you just hop over to the link that's provided in the submission, you can read a bit more about Baseline and what it's actually trying to achieve. It's actually built by a large bunch of organizations, Consensus, Microsoft, and Ernst & Young, among others. And it's submitted to the OASIS Foundation for more processing. So the original baseline implementation, they call it Radish34, demonstrated decentralized supply chain between 3 different participants, so buyer and 2 suppliers. It originally used the Whisper protocol for decentralized messaging. But because Whisper has been deprecated, the project has actually been moving towards NATS, which is great. I'm not saying anything bad about the NATS platform itself. But given that the whole purpose is for a decentralized messaging platform, we think that Waku actually fits this role quite well. And what we are going to demonstrate is that we've actually taken the baseline protocol and the Radish34 implementation and demonstrated that it can actually work on top of Waku itself. So what we're demonstrating in the solution is a few things. We're going to upgrade the Radish34 solution to use Waku. We're going to extend the messaging protocol within Waku, within Baseline to use Waku, and we're going to demonstrate end-to-end process flow using their integration tests. And I'll walk through the demonstration in the user interface. So what's the justification for this? Why do we want to do this? Because originally Baseline was sitting on top of a decentralized messaging platform. But because it was deprecated, it had to move to other messaging platforms. By using Waku and what the Waku protocol is providing, we can actually allow people to much more easily spin up baseline implementations. So instead of managing an additional component for messaging and then synchronizing between the multiple parties, we can talk directly onto a decentralized messaging platform. And that's very, very valuable, especially for large, medium, and small organizations who don't want to manage so much IT infrastructure. And of course, originally, Baseline was working on top of this decentralized platform. And the beauty of what Waku is doing is it's extending the Whisper protocol and then building more components around it. So it's a natural fit for what Baseline is doing. So I won't talk about the setup. Please feel free to launch up, check out the GitHub repo and follow the instructions to build it yourself. It's very easy. You just go into the Radish34 directory, run make test and make start. So make start and then make test. And then it will do auto processing. The one thing that's challenging is it uses quite a lot of resources. So make sure you have a lot of RAM, hard drive space, a good internet connection, and you're set. So you just run this, and then you'll be able to run this exact same demos that I'm doing. All right, so what we're seeing here is the main Radish34 screen. Now, the reason why it's called Radish34 is because the protocol that we use for the encryption, decryption, and a bit of the algorithms that are running behind the scenes is called Radish34. It's just the protocol that we're using. So what we're going to demonstrate is we've actually run the integration test prior to this. And so if you run the integration test, you'll see all the tests pass. 36 tests have actually gone and passed. What I'll do is, what I found also is that typically the messaging bus drops out connections after a few minutes. So you just run this restart.sh before you do any of your tests. And then you'll notice that the messages get flowing again. So what you see is once you run the test, you see a bunch of RFPs that are created. So just a very quick overview of what's happening here. The whole idea of a procurement process end-to-end is you issue an RFP, you send it to your specific suppliers, and the suppliers will respond with a certain quotes. So these are, say, tiered quotations for a certain item, and maybe a widget, or in our case, it's just a demo widget order for super widget, for example. So what tends to happen is then the suppliers we can issue a proposal back to the organization who's the buyer, and they'll say, you know what, I will give you volume discounts depending on how many you buy. So you put 100, you pay $10 per unit. If you buy 200, you're looking at $9. If you put 300, you're looking at $8.80. So these are volumes that are additional, so incremental. Now the challenge is usually in these systems is how do we make sure that different the buyers and suppliers systems are synchronized. That what I have in my records of your volumes are the same as what you have in your records. Now, organizations don't try to cheat each other. They're never going, because they have a working relationship. But it is very nice to have a synchronized standard baseline of records somewhere whereby we can reference so that both systems can synchronize on this record. And that's what Baseline does. So what I'm not trying to talk about Baseline. I'm not trying to deep dive into it, but I just wanted to give you a brief background of it. Do visit the Baseline protocol website. It talks a great deal about it. There's a lot of activity working on top of that. So having this integrated into Baseline is actually quite a good thing for Waku and for the Baseline community itself. So just very quickly, the purchase orders go through. Organization then decides to buy stuff and issue this purchase order, and the system will keep track of the interactions between the different buyers and suppliers. So the buyer and the supplier, their systems will be synchronized on the mainnet, in this case Ethereum, and every time they make a change, the record gets updated, and then both the information gets reflected. The messaging bus is a key component of this because this is where we do the off-chain communications. What I'll do now is I'll also demonstrate what we're actually seeing in the background. When I'm using that, the messaging bus from Waku, what I'm actually seeing is the messages passed backwards and forwards in a shared channel. So all of this information that's getting passed backwards and forwards is actually in the channel itself. So you can actually connect a chat bot to this, or in this case, the Waku chat app, and you actually see the messages as they pop up. So we can see that all these different JSON objects that are passing between the two different clients. In this case, in this demonstration for Radish34, we're using a channel called 0x11223344, which is really just a hard-coded channel for our demonstration purposes. But further down the track in subsequent iterations of this solution, you can imagine setting up specific channels for the two buyers and the buyer and the supplier through a shared messaging bus. So the power here is that this messaging bus exists in a decentralized P2P manner, and then we can use that as an enterprise bus to transfer information between different organizations. So what we've managed to do here, we've managed to take the Radish32 example from Baseline and then integrated that with the Waku.js P2P decentralized messaging bus. And we're using Waku.js and the Waku protocol as the enterprise bus between multiple different organizations. So now we don't have to share an additional bit of information such as the endpoint for the NATS messaging bus. We don't need to worry about setting up a connection between these two organizations. And furthermore, we don't have to worry about a single point of failure because this Waku.js and Waku protocol is decentralized. So anyone can actually connect to this and then use it as a messaging bus. So that's a lot of value that we're adding towards this solution. So what are some of the improvements and the next steps? Given it is a hackathon, I took a few shortcuts. First off, as you can see from my demonstration earlier, we didn't do any encryption. I mean, these Waku transactions, if you just hop onto this link here, you can actually see this is an example of the messages they send backwards and forwards between the organizations, and it's all in the clear, right? So there's no actual encryption that's happening here. Now, the beauty of this is that even if there are no encryption happening here, we actually do verify in Radish32 the signatures. So you can't just willy-nilly submit a proposal on behalf of someone else because those signatures still get validated. However, it would be good to be able to encrypt that and some form of channel management. So I envision that to be able to extend this further, we would have, say, the buyer listening in on their specific channel. Say my buyer public key is 01x. So a 0x1, for example, I would listening on 0x1 channel, and anyone who wants to form a business relationship with me would just submit to that channel. They can encrypt the message using my public key, and then I can just take that that encrypted message, decrypt it, and then form a second channel to which I can then chat to the supplier. So then we can have a discussion there. Furthermore, if I am the buyer and I want to issue an RFP to the supplier, I can actually look up their public key and then submit on their public key channel a request, and then we can then do some form of handshake to agree upon a private channel or another channel for which we can chat, which we can use encrypted messages as well. So that's one possible enhancement. Another enhancement is this has been done for only the Radish34 example implementation, so the baseline reference implementation called Radish34. There are two other baseline reference implementations. However, they're very tightly coupled with NATs. The reason why I didn't implement on those was because they were so tightly coupled that it was a bit challenging to try and rip it out and replace it. So there would be some extra work that could go into enhancing the baseline reference implementations to use Waku. And finally, looking at working with the baseline community to try and integrate this solution back into the baseline repository so others can use this Waku implementation. So that's all I have for the Waku integration with baseline. I must say it was much more challenging than I thought, mostly because the baseline protocol is actually quite complicated, and it's a lot of little quirks that are happening in there. Furthermore, Radish34 was not maintained because it was a deprecated an example of using Whisper, and it was really the only example that we had that used Whisper. So getting that up and running and started, and then integrating it into Waku JS was one of the challenging bits. Just getting the keys sent across properly, etc. But overall, I learned a lot, and I was very happy with the results that I'm presenting here. One other potential is to actually look at getting this example working from the UI perspective. It worked from the integration test perspective, but for some reason, when you actually run those steps in the user interface, they were not actually working exactly. So the final step with the verifier and the commitment proofs using zero knowledge proofs, that part didn't work. So that's not really on the Waku implementation and integration itself, but it's probably some quirk from the user interface perspective. So that's one part, and it's just that I ran out of time. So yeah, thank you for organizing this hackathon. Learned a lot, and looking forward to future hackathons as well. Thank you.